Solving quadratics by completing the square. So let's look at some steps we could do. Let's say we're asked to solve by completing the square. We have x squared minus 4x minus 7 equals 0. So we're in standard form, descending order equal to 0. And if the quadratic does not factor, we want to move the constant to the other side of the equation. So we're going to start with moving this minus 7 to the other side of the equal sign. So we can add 7 to both sides. We get x squared minus 4x, then we have an empty spot in 7. Then to complete the square, we're going to work with the x squared plus x side of the equation and complete the square by taking half of the coefficient of the x and squaring it. Well, half of the coefficient of x, our coefficient of x is negative 4. Half of negative 4 is negative 2. Negative 2 squared is 4. So to complete the square, we're going to add 4. Well, if we add 4 to one side of an equation, we have to add 4 to the other to keep everything equal, to keep it balanced. And so now that we've completed the square on the left side of our equation, we can simplify our trinomial, which simplifying in this case would be factoring using perfect square trinomial, where we take the square of the first term, square of the last term, sine of the middle, squared. And then on the right side, we have 7 plus 4, which is 11. Now, to get rid of our squared unit, we could take the square root of each side. If I take the square root of the left side, x minus 2 squared, I get x minus 2. And then when I take the square root on the right side, I'm going to get plus or minus the square root of 11. Then my last step to actually solve the equation would be to solve for x. I can add 2 to each side, and I get x is equal to 2 plus or minus the square root of 11. Now, if I had a perfect square here, it would be easy to change to 2 integer answers. But since 11 is not a perfect square, I can either leave it as a radical, simplified radical, which it doesn't have any perfect square factors, so this doesn't simplify any further. Or if I was asked to have my answers in decimal form, I could change that to a decimal and then do 2 plus that decimal amount and 2 minus that decimal amount. Let's look at a new example. Solve each quadratic equation by completing the square. Leave irrational numbers in simplest radical form. So x squared minus 6x minus 16 equals 0. I'm going to first add 16 to the other side. Then to complete the square, I'm looking for a half of negative 6. I'm looking at the coefficient of the x term. Well, half of negative 6 is negative 3. Negative 3 squared is 9. So I'm going to add 9 to both sides. Then on the left side, I can factor as a perfect square trinomial. Completing the square, simplest form would be x minus 3 squared. Square the first term, square the last term, sine of the middle, and then 16 plus 9 is 25. Now that I have the squared term isolated on one side, I could take the square root of both sides. So I have x minus 3 on the left, and then on the right, 25 is a perfect square. The square root of 25 is 5. So I have, when I take the square root, I have a positive and negative solution. So x minus 3 equals plus or minus 5. Solving for x, I can add 3 to each side. And then my answer is just going to be 3 plus 5, which is 8, and 3 minus 5, which is negative 2. So my two solutions are 8 and negative 2. Let's look at a new example. X squared plus 22x plus 21 equals 0. Same direction, solve each quadratic equation by completing the square. Leave irrational roots in simplest radical form. Okie doke, so let's subtract 21 from each side. Then to complete the square, half of 22 is 11. 11 squared is 121. So I'm going to add 121 to both sides of the equation. Then on the left side, I'm going to factor. So I have x plus 11 squared. And negative 21 plus 121 is 100. Now that I have a squared term isolated on the left side of the equation, I can take the square root of both sides. Square root of x plus 11 squared is x plus 11. Square root of 100 is 10, so when I take the square root, I have a positive and negative solution, so I have plus or minus 10. Isolating the x, I can subtract 11 from each side, so I have negative 11 plus or minus the square root, plus or minus 10. So negative 11 plus 10 is negative 1, and negative 11 minus 10 is negative 21. All right, how about one more example? Let's do same directions. X squared minus 2x minus 5. Let's add the 5 to the other side. Half of negative 2 is negative 1. Negative 1 squared is 1. So I'm going to add 1 on the left side, add 1 on the right side. Then on the left side, I can factor, simplify, x minus 1 squared, and 5 plus 1 is 6. Take the square root of each side. I have x minus 1 equals plus or minus the square root of 6. Square root of 6 is not a perfect square, so I'm going to leave that as a radical. To isolate the x, I'm just going to add 1 to each side. So I have 1 plus or minus the square root of 6, and I'm just going to leave that in simplest radical form. Okay, I think you guys are ready to try one on your own. Pause the video here and see if you can solve the quadratic equation by completing the square. All right, welcome back. Well, the 4 was already on the other side. That's a nice way to start. So then to complete the square, I'm looking for half of 10. Half of 10 is 5. 5 squared is 25. So I'm going to add 25 to both sides. Factor x plus 5 squared. And then 4 plus 25 is 29. Then I can take the square of each side and subtract 5. So I get negative 5 plus or minus the square root of 29. And I'm just going to double check to make sure my radical, that square root of 29, doesn't have any perfect square factors. It won't simplify any further. I'm just going to leave that as negative 5 plus or minus the square root of 29. All right, you guys are doing great. Let's try another. Pause the video here and solve by factoring the equation by completing the square. Welcome, welcome, welcome back. So let's subtract 11 from each side. Half of 8 is 4. 4 squared is 16. So I'm going to add 16 on the left, add 16 on the right. Then I can simplify by factoring. You get x plus 4 quantity squared equals 5. Take the square root of both sides. X plus 4 equals plus or minus the square root of 5. Subtract 4 from each side, and I have x is equal to negative 4 plus or minus the square root of 5. And that should help you guys solving quadratic equations by completing the square. We do have other methods, such as taking the square root, or factoring, or quadratic formula, but this puts you down the great road of solving quadratic equations by completing the square. Have a great day.